today the purpose is yeah, participants, today's purpose is to discuss the problems. So we gave enough time to practice you, to watch the video and practice you. So I hope you may have some doubt, and definitely you can discuss it with Mangaran sir. Uh, over to you. So I think I don't need to introduce you again. Over to you, sir.
Okay, sir. Okay, sir. So I have to answer for the participant queries, right, sir?
Initially, we can start with that. So, if they have any queries specific, if they while doing the assignment, if they come across with any trouble, then that we can discuss first, I guess.
Okay, sir.
Yeah. So it's participants. If you have any queries, please make it more interactive as we have very few people. Uh, so ask. You can unmute yourself, and if you want to share your screen, that also possible. You can do that. Um, so we can yeah first thing is we'll go in this way. So participants, if you have any queries, you can ask. Yeah,
So actually, we have shared the one assignment. We have given one
yeah,
assignment.
two assignments. Yeah.
First two sessions, we have given one assignment, that is CNN, gender classification. From that, if you have any doubts while doing that, please ask now. Any questions from participants? I think there is no questions. Sir, then how can we proceed, sir?
Yes, sir. So dear participants, you have to ask. We arranged this session uh, especially to discuss this thing. So please,
Yeah,
you may
while
have
doing
to.
assignment, if you faced any difficulties or
Yeah.
any problem, any doubts, you may discuss. You may ask me so that I will give the clarification.
Sir, good evening, sir. Actually, that time only we have tried. Afterwards, we did not try. And
Okay.
if you are having, you can show that execution so that we can see what are the steps again we need to be take
Okay.
up.
Okay, ma'am. Sure, ma'am. Okay. Yeah, I will give the demo on the same problem which I have given as assignment. Sir, 1 minute, sir. I will open this one using Chrome browser. Just a Sir, am I audible?
Yes, sir.
Okay.
Sir, shall we wait, sir? Sir, shall we wait?
Yes, yes, madam. And so the see today's session actually we plan to discuss the doubt. So you must have to ask doubt, otherwise it's quite difficult to proceed. Uh, I don't know if you didn't ask any doubt. Maybe he has to explain from beginning, from zero. So that is kind of not possible. So this session we dedicated only to clarify the doubt. Uh, so you must have to ask the doubt. Otherwise,
Sir, in first
So
day,
I don't know how many of you tried this assignment,
sir,
or how much. I mean, I think a few people already submitted it. I can see that, but maybe those submitted people, they may not have any questions. I guess I don't know. Yeah, Manivaran again, he joined. Um,
Sir, 1 minute, sir.
yes,
I'll join.
so please ask doubt. Please use the time. Yeah.
Is my screen visible, sir?
Yes, sir. Yes, sir. We can see the screen.
PDF, PDF, please. Sir, is my PDF is visible?
Yes, sir. Yes, sir. It is. It is.
Okay, okay.
Yes, sir. We can see your screen.
Okay, sir.
Yeah.
I'll yes, this is the assignment already we have given. These are the following steps already I have mentioned in the assignment itself. First one is loading the dataset. This is for gender classification. Second one is pre-processing. And third one is training and then validation set, followed by model architecture, and then model compilation, training, and finally evaluating the model performance. So the first step is loading the dataset. So what I have explained in the session, the same way I'm processing with this assignment also, gender classification. There we have seen vehicle classification. Will already we have done emergency versus non-emergency. Here it is male or female classification. Since it is binary class classification, the things optimizer and normalization, same thing we already done in the session also. The same thing we are going to use it here. So these are the required libraries we need to import first before starting this dataset reading. So NumPy, Pandas, Matplotlib, these are the very basic packages. And we are going to use this Keras library for model building. So NumPy basically it is for matrix calculation, and Pandas is for processing with Excel file, and Matplotlib is for visualization. And now Keras, so already we have done that input layer, dense layer. Dense layer means fully connected layer that we already have seen in the first session, MLP, multi-layer perceptron. And for improved performance and speed up the training process, we are using this batch normalization. And in order to overcome the overfitting problem, we are using this dropout technique. Same thing we already used in emergency versus non-emergency classification also. And there are two types of two types of models which we are going to execute this, which means we will execute the each and every step one by one. So here we are using sequential model one after another. This is also under this models under Keras module. And then optimizer, Adam optimizer, that also we need to import from the keras.optimizers. This is basically, it is optimization problem only. So because whenever we are forward propagating the neural network, and by calculating the error, we have to do the backward propagation, and by doing this one for number of iterations, so we are going to reduce the error, which means we want to reach the global minima. So that optimizer, Adam optimizer, we are using here. And the next one is we need to split, train, and then test data set, and also validation set for evaluating the performance of our model. From sklearn.model selection, there is a class called train underscore test underscore split. That also we need to import here. And finally, in order to evaluate the model and then check the accuracy of the model predictions, we are going to use another module, that is accuracy underscore score, that is method. That method we need to import from sklearn.metrics. And some of the modules are working with the help of operating systems, so that we need to import this OS also, operating system. So these are the required libraries we need to import first. And as usual, I have done this one using Google Colab. Mounting and unzipping the data set, all these things are similar to the exercise we already have done. So using this code, we can unzip this folder, whichever the folder I already shared. Okay, then the next step is we need to load the CSV file with image labels. So one is train.csv, another one is test.csv. There are two files already we have. First, we need to get this train.csv, and then with the help of pandas, pd.read_csv, just we will read this data frame, and I stored that one using this df variable. And this is our Excel file, and then we need to import this images also. So the variable name is image underscore folder. So these are the two things done. And next one is training and then validation set. So for that, already we have imported this one. And this is the way we have to do it: x underscore train, x underscore valid, y underscore train, y. So these are the validation as well as training data set, independent variable as well as dependent variable. So test size also 20% we have given, and random state is 42. That is for if any number of times you're executing, the same set of observation will be assigned, so that there will be no changes in the accuracy.
Sir, I used to
Yes.
get error in this particular portion, sir, when I used to try to run this portion of code. Y train and Y valid, I was getting like it's not properly defined or something. I was getting trouble in this portion.
No, ma'am. Actually, this train underscore test underscore split method, these are the attributes we have. So these are the variables we are assigning. These four variables we are assigning in order to store the splitted data set, which means 80% will be assigned to 80% of the feature variables will be assigned to X train, and 80% of the target variable will be assigned to Y train, and 20% of the predictors will be assigned to X underscore valid. And so I don't know why it is showing that error. So have you assigned this data frame properly, ma'am? Data frame.
Maybe that DF class, I think
There
I
only
missed.
this here
Yeah.
only the problem may come. This too.
Okay. Okay.
Check it, ma'am.
Okay.
Check it once.
Okay, sir. Okay.
And then next, pre-processing the data. So for this pre-processing, I'm using here Computer Vision 2 library, CV2. This we have not used in the exercise, especially for reading and then resizing the images we are doing. This is the library where we can do this process easily. So for that, we are going to define a function to pre-process an image. So the function name is pre-process underscore image. and we are passing two parameters. One is image underscore path, another one is target underscore size. Target size is 224 cross 224. And now using this variable, we are going to read this with the help of CV2, and that we are going to store it into the image variable. And again, we are going to resize that one using this image variable, and then target size already we have defined, right? Target size is 224 comma 224. So using this one, we are going to resize all the images, because all the images are not in the same dimension. So we are going to make it uniformly, so that with the help of resize method, which is available in CV2. CV2 means computer vision version 2. So next, just we are going to take the image and we are going to divide it by 255, because that is the upper limit, 0 to 255. And the final, the image value, we are going to return to the calling function. And that is one function. Another function is custom underscore data underscore generator. Here we are going to generate our number of batches, number of samples, all these things. So just instead of doing that one, just we have defined two functions, and using that function, we are doing all this kind of pre-processing. So shuffle equal to true, and then target size, batch size, and file path, labels already we have. Just we are going to take all these parameters. While calling this function, we are passing all these parameters. So using all these things, first thing is the number of samples. So file path, we have complete sample. So by using this len method, it will calculate the length. So that length will be the number of samples, and then number of batches. How many number of batches? Batch size already we have defined. Just we are going to divide this number of samples with this batch size. So we'll be getting batches. So for example, if we have 200 samples, the batch size is 100. Just for example, number of samples 200 and batch size is 100. So totally we have 2 batches, right? So likewise, first we are going to see, maybe you have doubt that why we are having these batches, because if you are supplying the complete data set at one full stretch, then the calculation will be difficult. So that we are going to divide it into many number of batches, and then we are processing. And using this a range function, we are going to make it as, with the help of this NP, we are going to make it as a array. So that we are going to store it into this index underscore array. So now using this while loop, we are going to check this whatever the value we have already done with index underscore array. Just we are going to shuffle it using this np.random, and then we are going to make it as a loop here. So batch underscore index in range, number of batches we are supplying here, and then we are going to process it for those many number of times. So how many number of batches are there? Those many number of times this particular for loop will be iterating. And one more inner for loop also we are using. This inner for loop will be working with this pre-process underscore image. Here we are supplying this image underscore path and then target size. So here also one more method we are using, that is I location. This will show the index of that particular each and every image. There is a file location, right? That one. So labels dot I location. If required, you can do this one pre-processing, and if not, you can follow the same which already we have done in the session itself. But if you do this way, then we will get more accurate result, because if the pre-processing is done well, then ultimately it will give the impact on the improved performance of our model. So after doing this pre-processing, just we are going to append these images into the batch underscore data. So batch underscore data is the empty list we have already created. See here, batch underscore data and batch underscore labels. So each image there should be a label, since it is supervised machine supervised learning. Okay, supervised learning. This image also, all the images are having as well image as well as labels. So then only model will get trained, right? All the male images tagged with the male, and all the female images tagged with female. That is a label. So now finally, we are going to get the yield by using this batch underscore data as well as batch underscore label. And here the batch size is 32 and target size is 224 cross 224. And here we have generated this train underscore data underscore generated. So like this one, x underscore train, y underscore train, and batch size also we already done that 32, and target size also there 224 cross 224. So this is the custom underscore data underscore generator. This is the function we already created. See here, we already defined the function here. Now we are calling this function and we are passing all the parameters. So this particular function will generate all these things, and then it will go. Similarly, this is for training, as well as we just call the same function for validation data generator. So this will generate the data according to the instructions we have given in the function definition. You go through these one line by line, each and everything. Why are we using this each and every syntax and methods, all these things, then you will get to know exactly why are we doing all these things. Okay, so definitely this pre-processing will give the more impact on the accuracy of our model. So defining the model architecture, this is as usual sequential model and the convolution layer we are using here, and also max pooling. Since it is CNN, convolutional neural network, we are using convolution 2D and max pooling 2D. This is for pooling layer we are using for dimensionality reduction, right? Because in order to reduce the learnable parameters, if more number of learnable parameters will be there, then the execution time and the training execution time will be more, and computationally it will be more complex. So in order to reduce that, we are using this pooling. Again, the pooling size is more, then obviously the model will extract only less amount of information. That also will be a problem for predicting more accurate result. So we have to choose this one carefully. And the flatten. So in CNN, we are using two main things. One is convolution layer, another one is dense layer. So dense layer is fully connected layer, which is MLP, multi-layer perceptron. So in order to supply the data to the dense layer, we need to flatten, because one dimensional value only will be accepted by dense layer. So that we need to flatten the two dimension, which is given by the convolution layer. And again, if the model will be facing the overfitting problem, then that also we need to handle. So for that we are using this dropout technique, and some other techniques also there. Okay, that also, see, in order to make the full-fledged project, and in order to get more accuracy, we need to know all what are the supporting techniques, what are other techniques, and what way this is improved one compared to all others. Then only we will fit the exactly suitable technique or model methods to this particular problem. And define the model. Yeah, this is the way we have to define the model. Just it is a kind of class and objects, how we are creating an object for the class. Same way here, model, and then assignment operator, sequential. So now we have defined the object for this sequential class, that the object name is model. So using this object, we are going to call the required methods in order to perform various operations. So model dot add, using this add method, we can add number of convolution layer, pooling layer, and the flatten layer, dense layer, everything. Whenever, whatever you want to add to this sequential model, using this sequential class object name is model. Okay, so model dot add. So the parameters convolution 2D. So here we have to supply this 32 filters, and each filter the dimension is 3 cross 3. And here activation function we are using ReLU in order to maintain the non-linearity. And if it is fully connected layer, we are using sigmoid as a activation function. And the input shape is as we all know, 224 cross 224, and since it is RGB 3, okay, red, green, blue. So now max pooling also we are using after each convolution layer in order to reduce the dimensions. So directly it will impact the learning parameters. If the dimensions are more, then learning parameters will be more. Then obviously processing those many number of learning parameters, then we need high computation power, as well as it will take more number of time. Training time will be higher. So max pooling, the filter size is 2x2. And then model.add, we are adding this one more convolution layer, but this time the filter number of filters are 64, and each filter size is 3x3. That is the standard one, 3x3. And activation function as usual ReLU. And this time no need to mention the input shape because it is a sequential model. Already we have supplied this first convolution layer. So the output of the first convolution layer will be the input of the second convolution layer, as we know. And again, here also we are using this max pooling in order to reduce the dimension, which means directly we are reducing the learning parameters. But one good thing is convolution layer will not make more learning parameters as compared to this fully connected layer. We know that already. Architecture completely we have seen. If you have any doubt, just you rewind the videos, which means already you have the recorded video, you can go through it once. So max pooling, again one more also, 3 convolution layer we are using. Why? If number of convolution layer we are using more number of convolution layer, then more number of information we are extracting, right? Because each and every convolution layer there are a number of filters, so each and every filter going to extract the information. So now and that particular output will be given to the next convolution layer. So which means we are going to do the information extraction refinement in each and every convolution layer. So the only thing is, if more number of convolution layer, then the computation will be difficult. That's the thing. So basically we all know that deep learning is a black box model, because no one can understand what is happening internally, because it is connected with matrix and so many multiplications, or the element wise multiplication and pooling layer. And when it comes to this fully connected layer, there are many hidden neurons are there. Each and every neuron are connected to the input features, and every connection we are going to supply the weights, and every neuron we have to supply the bias, and all this we have to do it, right? And also sigmoid function for maintaining the nonlinearity. So we cannot interpret this kind of deep learning architecture, what is happening internally, easily. Okay, that's why this interpreting this one is very, very difficult. But machine learning interpretation will be easy. So yeah, there are 3 convolution layer we are using in this architecture, and then flattened layer. So in order to feed the input to the fully connected layer, we want to convert this into one dimension. So with the help of this flatten, we are going to achieve this one. And next one is a dense layer. So only one dense layer, hidden layer, and another dense layer is output layer. Okay. So here 128 neurons we are using, and the activation function is ReLU, and obviously the output. So generally output layer we are using sigmoid function, because since it is binary class classification, for classifying this output, sigmoid function we are using as activation, and rest of the things we are using ReLU, rectified linear unit. Just you go through that, what is that, what is the process of rectified linear unit? Actually, rectified linear unit will avoid this vanishing gradient problem. There are 2 problems are there when we are doing this back propagation. One is the vanishing gradient, another one is exploding gradient. Because in each and every back propagation, we are going to update the parameters with the help of gradient descent optimization algorithm. When we are doing this back propagation partial derivative, sometimes it leads to gradient exploration. Sometimes it leads to vanishing gradient. You know it, I think. Otherwise, I'll explain. Exploding gradient means the updated value is very, very large, which means it is completely exploding, right? And the vanishing gradient means the previous parameter values and the new gradient values, there is no much difference. Almost both of them are equal, which means our error will not be optimized. right? That convergence will be very, very minimal, which means there will be no improvement in the error. So that is, these two are very big problem. So especially this ReLU activation function will this one overcome this vanishing gradient problem. Okay, and few more benefits also there using this ReLU. Okay, so after getting complete understanding of all this optimization, ADAM optimization and activation functions, pulling everything, then making this model with more accurate result very easy. Otherwise, trial and error basis, if you try to do it, it will be completely cumbersome, which means very difficult. See, there are many methods, modules, all these things we are using, right? So trial and error basis, if you are doing, then how many possibilities, how it is possible by doing all these combinations, permutations, right? So next, these are the model summary. So the first convolution layer, 896 parameters we have. And you know that we supplied 224, but it converted into 222 because we are using 3x3 filter. We know it already, 224 minus 3 plus 1. That is the formula in this convolution layer. And why we have 32? Because 32 filters we are using. So that definitely we will be getting 32 feature maps. So that we are going to, so totally 896 parameters. And next we are going to use this pooling layer in order to reduce the dimension. So we reduced to exactly half. Okay. So pooling layer, already we have seen here, right? 2x2 matrix, the filter sizes. So 2x2 means exactly we'll be getting half. And then next convolution layer, again 3x3 only. So 111 minus 3 plus 1. So we'll be getting 109 here. And the 64 filters we used in the second convolution layer, so that here we will be getting 64 feature maps. And these are the number of parameters, because filters are increased, so that learning parameters size also increased. And again, not to reduce this dimension, we are using this pooling layer. It is exactly reduced to this 54 cross 54 into 64. We know it already. This filter feature map size will not be changed when we are applying this pooling layer. Only x and y axis pixels values only will be changed, and the filter size 64 will be remain same. And since it is pooling layer, there is no parameters. And the convolution layer 3, again 54 minus 3 minus plus 1, so 52 cross 52. And here we are using 128. See here, the filters we are increasing 32, 64, 128, like that we are increasing. So when we are increasing more number of filters, then obviously the information extraction will be done that many number of times we have to multiply. Okay, so we'll be getting 73,856 learnable parameters. And pooling layer we are applying. Yes, we used only 3 convolution layers and then flatten. So when we are flattening this one, just you will multiply 26 into 26 into 128. So we'll be getting 86,528. And that we are going to pass it to the fully connected layer, that is MLP, multi-layer perceptron. And here, see that the number of learning parameters are too high. Okay, then that we are going to see, even if we have done these many pooling layers, we are getting this much learnable parameters. If there is no pooling layer, then this is very large, these learnable parameters. And finally, this 128 will be getting, and plus 1, that is for one bias value for the output layer neuron. So totally we'll be getting 129. Detailed way how we have done these things, each and every step already there in the exercise. You can go through that. And next we are coming to this compiling our CNN model. So model.compile, using this method we are going to achieve this model compilation with the help of Keras module. So here optimizer is Adam optimizer, and last function is binary cross entropy we are using here, since it is binary class classification. And again binary class cross entropy also, that formula is there, right? Minus 1 by m summation of I equal to 1 to m, and y minus log of yp. Yp means y prediction, y means target value, that is ground truth value, plus 1 minus y log of 1 minus yp. So that is a formula for binary class entropy for finding the loss. This particular binary class entropy will be calculating the error. What is the error? So based on this value only, we are going to apply this optimization in order to reduce the error. And the metrics which we are using here is accuracy. There are two metrics. One is accuracy, another one is loss. So accuracy means it is in the increased level. Loss means it shows the decreased when you plot the graph. So training the model, so 20 epochs we have done already. So using this model.fit method, we can do this with the help of training and then validation. We are doing this for training separately and then validation. So we'll check it. Training and then validation, if much difference is there, then definitely model is facing this overfitting problem. So since already we have done that dropout layer and other overfitting handling techniques already we have done, so we'll check it here. So 20 epochs, and each epoch some improvement we are seeing in the training as well as in the validation loss accuracy. And so finally we will evaluate the model performance. So need not check each and every epoch loss accuracy. Instead of that, using this method, we can just check the accuracy level. Otherwise, we can plot the graph so that we can easily understand. So using this matplotlib, this is a graph. Training shows blue color and validation orange color. See here, completely it is showing that overfitting. See? Training loss is around 0, but validation there is no improvement. Maybe first one up to 2 epochs, maybe some improvement is there, but later on, but it is in the increasing level only, which means error is not decreasing. Okay, so we need to do some kind of technique so that we'll reduce it. And here also model accuracy, again model accuracy, see this training accuracy is increasing, but the validation accuracy it is in the flat line, which means there is no improvement in the accuracy also. If there is no improvement in the loss, definitely we can't expect the accuracy also. So now we are going to do this hyperparameter tuning in order to overcome this overfitting problem, and then accuracy also. We are getting very less accuracy, right? So that also we are going to improve by doing this hyperparameter tuning. Now these are the ways we are going to tune our parameters in order to get improved accuracy. So this is also already there in the exercise. So number of convolution layer we can increase, and pooling layer also. Convolution filter size also we can increase, and then size of convolution filter also we can change. Similarly, pooling type. There are two pooling types are there. One is same, another one is valid, right? Same means we have to add some dummy, and valid means we need not add, but the original size will be decreased to the feature map. And the padding technique also, padding technique only same and then valid, and pooling type we have different types, right? And also changing stride value also. So generally we are using 1x1, 2x2. If we go more than that, then again extraction of the information will be less, then that will directly impact the performance of our model. So the stride value we should not keep more. Then that is about convolution neural network parameter tuning. And next, fully connected layer, which means dense layer hyperparameters, which means activation functions we can change. ReLU we have used, and we can use some other of the hidden layer, as well as we can increase the hidden layer neurons, as well as hidden layers also. Only one hidden layer we used, but we can increase into 2, 3 also. And similarly, number of epochs we can increase. And then optimizer, Adam optimizer we were using, we can change that also. So again, we are going to do it by tuning these parameters. So here we are using average pooling. That is also there are many pooling techniques already we have seen, right? Now here we are going to use here average pooling, batch normalization, dropout. So these things already we have not used. Okay, that's why we are getting very less accuracy. And here also yearly stopping. This is also another method, because see, if you are executing for 20 epochs, which epoch we are getting more accuracy, better accuracy, we don't know, right? So that's why we are importing this yearly stopping. So what it will do, it is there already in the keras.callbacks. Whatever the best result we are getting, it will store that one. Okay, so that's why we are using this. Yearly stopping, see, for example, when we are doing this execution for number of epochs, but even after 20 epochs, 30 epochs also, there is no performance improvement. Then what should we do? Instead of executing that one continuously, we will stop it early. So that's what early stopping. And at the same time, if you want to store the better model, that option also available. So that also we can do it. But early stopping here is if there is no performance improvement after, which means continuously for 3 to 5 subsequent epochs, there is no improvement in the loss as well as in the accuracy. Further, if you are continuing, there is no use, right? So we will stop it early. So that's what early stopping. And optimizer and rest of the things. So again, same thing. First convolution layer. Previously we were using normal pooling, but now we are using average pooling. So pooling techniques we are changing. And previously we were using valid, but now we are using same padding technique, which means we are adding the dummy bits, and then we are maintaining the same dimension in the feature map compared to the original data size, right? And activation function same ReLU. And yeah, so here we are using batch normalization. Previously we didn't use this batch normalization. Now we are using, and the dropout also previously we didn't use. Now we are using dropout. So dropout also most important technique here in order to reduce this performance lag. What is the dropout? For example, in the we are using this dropout in the fully connected layer, not in the convolution layer. That is also noted point here. What is that actually? We have number of neurons in the hidden layer, right? So maybe sometimes the neurons which are connected from the input feature, maybe some few neurons will be dominating or influencing. So which means it will take the input and then that particular neuron will influence the entire hidden layer. Because of that, maybe the performance lag will be there. So what we are doing, we are going to randomly just to drop the link between input feature and then particular neuron. So that neuron, which neuron we are going to just to disconnect the link, that will be done automatically, okay, by this dropout method. So 30% we are going to drop out. For example, if we have 100 connections, so 30 connections we are going to remove it. So that this one we are going to do it randomly. There is no fixed rule. And by doing this one, if any of the neuron will be influencing or will take the feature as it is or dominating, so those things we can we can, you know, stop those kind of influencing process. So if one particular neuron will influence, means definitely that will affect the performance of a model. That's why this dropout technique also most important. So by using all these things, definitely we can improve this performance. So whatever I'm showing here, this is one kind of way, and there are many ways. Okay. And early stopping also. See, already I told you, right? Early stopping. So here attributes we have to pass. Monitor validation loss using this. See, what is this validation loss? See, based on which particular metric we are going to check the performance. See, for using this validation loss. For 5 subsequent epochs, the validation loss, if there is no improvement, which means patience. What is patience? Patience means how many epochs. So 5 times, if the validation loss is same, there is no improvement, then simply it will stop the process. So that is what this early stopping These also important. And Adam. So learning rate for this Adam optimizer, we can fix it here. By default, it is 0.01, but now we are increasing, which means 0.001. Sorry, we are decreasing this learning rate so that the learning will be done better. So that's what we are checking. So if not, then we will update this one. We will change this learning rate also. And model.compile. So again, binary cross entropy, and the metrics here is accuracy. And number of epochs 25, previously 20, now it is 25. And again, training and then validation, just we will get it from the function which we have already defined. So this time we will check the performance. So same. So just to see here, now the performance is improved. So blue color and then orange color, see that training performance also good, as well as validation performance also good. And the most importantly, the model are not facing this overfitting problem. That is a good thing. Okay, so even if you are getting 90% accuracy also, if our model is facing overfitting problem, definitely it will not give the best accurate result for the unseen data. That is, overfitting is the most important problem in machine learning and deep learning. So similarly, loss also, see here, loss also, training as well as validation. So it is really good. See, actually training loss is reaching zero, close to zero, but validation loss is around 0.25 kind of thing. It is really good. Okay, because the images are more, and then 224 cross 224 pixels are there. So it is not that much easy to make this training as well as validation very close. So there is no overfitting, and also model accuracy also acceptable level only. Okay, so again in the same data set we have given test also. So using this test data set, you can check out the accuracy. So this is what all about this experimentation of this one. I think you got some idea from this one. If you have any doubts, you can ask me.
So thank you, sir. We will try with this next few times.
Thank you, ma'am. Any other doubts?
Thank you, sir. Today, actually, it was a very detailed explanation. We got an idea, but
Okay, ma'am.
just as a beginner, since I am trying to understand now exactly what is deep learning techniques and all. So, what is the roadmap you'll suggest so that we can also do this implementation? How you have
Yes,
done?
yes, ma'am. Actually, the thing is, it's within 10 days or 20 days, it's not that much easy to cope up with this. So each and everything like
Yeah.
optimization and then activation functions, normalization, everything, there are many techniques are there, and each and every technique, the working principle also we need to understand. Then only we can choose the right technique. That's what. For that, it will take 3 months time, definitely. Even if you are fast learner and you are completely enthusiast on this deep learning, and every day you are spending 4 to 6 hours also, definitely it will take 3 months. Then you will be perfect in this coding, and you will make some result findings for your research.
Sir, actually,
Okay, sir.
from where exactly we need to be learn this techniques? Like correct path we need to be learn means from where exactly we need to, which website we need to use, which source.
Actually, ma'am, there are many excellent courses are available online, which
So
means
please share,
Coursera,
sir, if you are having anything like that. Like
Coursera
fully,
courses,
it should be
Udemy.
cover the from start to zero to like it has to start.
Okay, ma'am. I will
Like
share the
that, if you
links
are having
actually.
anything, please share the link, sir. We will
Okay,
watch
ma'am.
and then we will see that the course is suitable for
Okay.
us.
Okay, ma'am. Sure, ma'am. And whenever you find any difficulty while getting the result or doing the code, if you are getting any errors, there are many blogs also there.
Yes, sir. Yes, yes.
Medium is there, Data Science Central. Likewise, so many blogs are there. you can get the help from that. And Udemy courses also there, Coursera courses are there, and some of the YouTube also you can, but YouTube you will not get this much in-depth knowledge.
Yes, sir.
You may get some kind of overview, and for just for learning practice you can go with YouTube, but for in-depth and research point of view, learning this deep learning completely, definitely you have to undergo with some kind of courses.
Okay.
Now I will refer ma'am those websites.
Please, sir. Please, sir. Thank you, sir.
Definitely ma'am. Anything?
Sir, can you share this whatever you have explained with us?
Sure ma'am, why not? See, whatever I'm sharing, see, resources are for sharing only. Whatever the resource, that is only for sharing. So
Yeah.
need not hesitate to ask these things. Definitely we will share.
Okay, sir. That's what when we start doing implementation. So, we need to start with the simple examples or how to go with the flow. Since I have joined for research recently,
Okay.
yet to begin. I have a mind in my mindset I need to work on image data set using deep
Okay.
learning models. So I'm not
Okay.
getting the path how I need to proceed or what is the way I need to follow.
Okay. Actually, one thing is we need not memorize or remember the code because code is already available, but we need to know in order to resolve this problem or in order to get more accuracy, what are the different ways are there. If you know the ways, then getting the code is easy. Everywhere it is available. Internet is full of resources only. We know it, right, ma'am?
Yeah,
So
yeah.
only the ways, what are the different ways we can approach this problem? If we have that idea, that is highly sufficient. But for that only, we need to do this study for 3 months.
Okay. First, we need to understand what are the available techniques are there.
Yes, yes, ma'am.
Then, what are the approaches that are there to solve that
Yes.
problem and how I can improve in that.
For example, one simple example I give you, ma'am. Actually, for someone have done one, for example, I am explaining you with this gender classification. Here I'm using this Adam optimizer, ReLU activation function. But for your problem, I cannot sure that the same kind of metrics will be suitable for your problem because your problem nature is different. Everything is different, right, ma'am? So for what we have to do, we need to know how internally this everything is working, like how we have done this, learn this CNN architecture completely in depth in the architecture as well as mathematics as well as the derivative part, everything we have done now, ma'am. Same way we have to do all this.
Okay.
At least for whichever the problem you are working for your research, what are the techniques or models are helping in order to solve that one, at least that one. For example, CNN, RNN, only these few models you need to know everything. You need not learn all these things. It is impossible because deep learning it is a kind of not possible. But image, for example, you are going to work with image related problems. So what are the deep learning architectures are there related to image? So example, the most popular architecture is CNN, convolutional neural network. So you need to start your study from this CNN. And after the CNN, is there any better model, or how can I improve my model by using pre-trained model? There are many pre-trained models also there for image classification itself. But if you want to build your model from the scratch, it will take a lot of time and computation power we don't have. So that people are moving using these pre-trained models. So VGG16, like so many pre-trained models are there. So if you use pre-trained model, and how I'm going to exactly match those parameters which will help us to solve my problem. So these things, ma'am, I'm telling.
Okay, sir.
See, once you are starting now, now you have this idea by attending this workshop. That is highly sufficient. I'm telling you, definitely. This is not a kind of pricing. It is a exact thing I'm telling you. So this with this idea, just you have to go forward.
Okay, sir. Thank you for
Anything
the
else?
information, sir. At least I got one roadmap or idea, so how I can proceed. Thank you very much.
That is the motto of this conducting this workshop.
Yeah.
Thank you, ma'am. Thank you, Shah, for sharing your feedback. Anything
Thank
else?
you very much, sir.
Actually, madam, you asked details, right? I mean, contact details of Manivaran sir.
Yeah.
You got that one, or
No, sir.
okay? I think he already shared that one in one of the sessions. Uh, we will definitely share it in the WhatsApp.
Okay.
Okay.
Um,
Then I think
yeah, if
questions
there is
are.
no other queries, then we can wind up the session. Thank you so much, Sir Manivaran, sir. You spend, even this is an extra session, even though you are spending it and answering all the queries. These are all a great thing. Thank you so much. And even I just went through the feedback that given by the participants. Most of them are thanking you for your the initial two sessions. That and all got a very good start to this workshop. Thank you
Thank you,
so
sir.
much. Yeah, thank you so much, sir. It means a lot for us. And definitely we will again collaborate in coming workshops. Uh, Thank you so much.
Thank you, sir. Thank
You
you
are
for
a
the.
good, yeah, you are a good teacher, sir. So
Thank you. Thank you.
people are accepting it and people are understanding it. And
Yes, sir.
dear participants, one request. As I said earlier, this workshop officially is over, but the connections that you are making here, uh, that should uh, that should not over. That should carry in future too. So the whatever the discussion you are making, whatever the collaborations you are making, that is all. That is another purpose of these kind of workshops. So please use those things too. And we are more than happy if you do such kind of collaborations. Then thank you so much. Now we are winding up all our deep learning workshop here. Um, Thank you so much, dear participants. And definitely thank you so much, Manimaran sir, for spending your valuable time.
Sir,
Um,
thank you so much for making this platform and these active participants. Really, I'm also very happy to share this information. Without this opportunity, how can I interact with these people? So, first of all, my wholehearted thanks to you, sir, making this such a wonderful platform. Thank you so much, sir.
Thank you, sir. Thank you for your kind words. Thank you. Then we are winding up the session here. Um, so whenever you need any help, you can use that WhatsApp group, or you can uh, drop an email to us. Um, yeah, thank you so much. We'll meet in maybe upcoming workshops.
Thank you, sir.
Thank you, madam.